One of the things that you'll run into in React applications at times is performance problems. And very often these are usually caused by large DOMs, lots of elements in them, and there are all sorts of ways of addressing these. I'm going to attack a particular problem that's annoying me personally in this video just to show you how I go about trying to improve the performance of UI when I find a problem. So hopefully you're using Fulcro Inspect in your work when you're using Fulcro. And what I'm going to do here is open up the template, and I've already done this just for speed here. I've started up shouldComponentUpdate on this project. I've already started the main build, and then I did start a REPL over here. That's not the right project. I started a REPL over here and ran this, and then ran start in the REPL. And so this started up the server on port 3000 for running this application. But then I changed the UI of the template, so you can look at the template's README to start it up. But I changed it and just added this new placeholder component. And I just gave it an ID and a name, and then I gave it an initial state that ignored the parameters but generated a random UUID for the ID, and then used closure spec to generate arbitrary strings for names, just so I'd have some data. And so you see, I just specgen alpha and spec alpha, and then generate. And then in the root, I changed this guy from this top Chrome thing. I just am ignoring everything above line 196 there, so that it would have an initial state of 1,000 placeholder elements and then render them. So what this looks like in the UI is I load this and it just gives me 1,000 random strings as DOM elements. So that's fairly hefty React thing. And this is not the thing I'm trying to tune. The thing I really want to tune is inspect, because when inspect has this size of a database table, it gets pretty pokey right now. So you're going to get to see a little bit about how inspect gets developed. The other change that I made to the template to get this going is in the shouldComponentJS Eden file. I went to the main build and I changed this to use the WebSocket preload because it's a little easier to deal with the Electron version of the app as opposed to the Chrome extension. So this just keeps everything a little easier to deal with. So I changed the preload from preload to WebSocket preload, and then I can show you how to run the Electron version of this. Okay, so that's all that's going on the template here. I'm just generating a project that can connect to inspect and perform badly. Okay, so I'm going to shrink that guy out of the way because it's really irrelevant beyond that. Okay, inspect, just a quick little overview of the project. This shells directory contains the actual build for running Electron, and Electron runs both a Node backend and a V8 front end. And so really what you have to do is start shouldComponentJS in this project, which I've already done right here, jump to its interface, and then make sure Electron main and Electron renderer builds are running. So that's the back end, and this is the front end. This back end creates a WebSocket server to listen for applications connecting. So if you have that WebSocket preload, it goes looking for this guy at a well-known port on localhost. Okay, so that's how I get that running. And then in the terminal, you can change directories into the shell's Electron directory, do a yarn to install the packages, and you need to, of course, have done that here if you've cloned this guy. And then I've also changed the deps for inspect to include this library by Peter called Tuft. It's a great little library for doing performance measuring, and I'm using 2.10 RC4, which works a little better with ClojureScript than the 2.10 release. I seem to remember that's why I'm using it. It's been a while since I looked up that stuff. So anyway, I've got Shadow running both builds with this Tuft library added to the deps. If you've checked out inspect, it won't have this by default. So I did add that to deps Eden. And then I'm going to go into this Electron directory. I'm going to do yarn to install the yarn deps, or npm install, whichever you prefer. And then you should be able to run Electron dot And I think on my path always includes node modules slash dot bin, so I kind of automatically get, executables that have been installed by node, or you can do the npx kind of stuff. So I'm going to start that up, and that'll start Fulcro Inspect with the build that I'm interested in. Okay, so now if I go to my application, load it, I should see Inspect over here, refresh. Okay, things look good. Looks like I'm talking. Okay, now to show you the performance problem. I'm going to open this ID table, and I clicked on it, and you see 1, 3. So it's about 5 or 6 second response time there. Now part of that is React overhead and just making the DOM for 1,000 new sub elements. It's going to be expensive to expand that in React or anything else. Like adding that many DOM elements to the tree is just expensive, especially when they're formatted, etc., etc. So I'm not sure how much hope I have of speeding that up. Possibly some, but I do expect there's going to be some cost related to that. Now, in order to optimize, of course, I need to know what's actually slow. And so the things I'm interested in are, for example, if I'm going to try to search for one of these things, arbitrary things, let's say I'm going to search for 3C92. Press enter here, and I should see something light up. You just saw it took a little while for that to light up, so this is kind of a use case. And then I might go down here and click on the expand. Oh, that was actually pretty fast. Oh, that was it expanding. Sorry, that's how long it took. My CPU is still burning up here. So you see this is really annoying to use. This is quite slow. Wow, it's still going. Right, so see this kind of table is just intolerably slow. Okay, so let's see what we can do about this. First thing I want to do is just show you a little bit about the basics of measuring things with Tuft, because you can't really optimize something unless you can figure out exactly what's wrong. So the layout of the project here, this renderer is just a really light thing over top of the real UI. And so data viewer over here is the namespace where all of this rendering happens. And so it's pretty straightforward. I didn't expect that to get that hung up. Wasn't getting that hung up earlier. I'm going to maybe reload it. Oh, right, it won't reconnect to the app unless the Electron one's still in sort of, I see what I did. I accidentally highlighted some things. Okay, so open that. All right, so while that's working to expand, let's look at this data viewer. So most of this stuff, isn't involved. It really is this namespace that does the data viewer, and so let's glance at how that's written. So if we look, data viewer is a function. Then there's this data viewer component, and the data viewer component gets some stuff like what search string is currently being used, etc. And then it calls this render data, and it passes in. This expanded is a set of paths in your app state that you currently want expanded. I don't remember what static is for. Search is the search string you've typed. Obviously toggles this lambda here. Etc. And then the CSS is being pulled from this component local CSS. So I don't expect that to change during runtime. The CSS should just be a constant. Okay, so let's go look at what render data does. So render data, is just a recursive function which calls render vector, which calls render sequential, which calls rendered ordered list and render data. So you see it's like this, basically this just pure functional recursive rendering algorithm that doesn't really involve React much. So I already suspect I'm going to have some issues making this faster. I mean, if I look at some of these algorithms like right here, turning that into, let's see now, map v with a concat. All right, so turning that into a map cat, maybe memoizing the sort, right? I can potentially save myself some overhead there, but I don't know exactly what's costing what. So let's do some measurement. Now, as long as you're holding a thread, Tuft can measure things within that thread. But because we're also going to be measuring things in components that React renders asynchronously, we need a way to collect up our measurements. And so Tuft actually supports this sort of thing. I'm going to glance at what I did here on master, so I don't have to go reread the docs to figure it out. This is stuff that I'm going to show you here in a minute. Here, this is it right here. This is the little bit of stuff that I need. Okay, so I'm going to go to the main. No, not even main. I can just do this in the data viewer. All right, so I've added Tuft. This side effect and adds an accumulating handler to Tuft's infrastructure. And then this makes a function that I've exported where I can just call it from the JavaScript console over here to dump stats. So basically, when you profile things, here I'll just show you. So let's say I go up here to render ordered list. So in here I could say, and actually I'm just going to go up here to Tuft and say refer profile and P. So profile takes a configuration, and then you can do nested calls to P with keywords to name the sections you want to measure. And in this particular case, again, I'm kind of assuming that this might be called asynchronously, and so I need to start profile, which does the gathering, and then P to measure a particular thing. Okay, so if I do that, come over here, I'm going to let that hot code reload. And then I should be able to call that stats function I just made. I may have to, or it may not have, actually didn't hit render ordered list. That's why it didn't measure anything. Reload my app to get it connected. Nothing measured, but if I pop open this list here, after a couple of seconds, oh, still nothing. So I must not be hitting that function at all. Let's go towards the top. There we go. So render data took 3 seconds. Oof, beastly. And calling that function is a side effect that clears the current collection. So if I, do something again, it'll recollect data, and I'll get my numbers. Okay, so now I've got a way of measuring badness. Okay, so we've got this sort by thing. Let's measure that. And depending on, since this is inline, it'll get caught by that top level profile. And I should just be able to see. Okay, sort by thing. Okay, so it's saying that it got called 3 times. The minimum time it took was 2 milliseconds. Half the time it took at least 2.78, etc. So that's a fairly expensive one, but remember I'm doing recursive calls to render data here. So even though it says this particular algorithm is slow, a lot of that time is probably being consumed by these recursive calls to render data. Okay, so what else can I do here? So that's sort of the measurement technique that I'm going to play with to figure out where my hotspots are, because it's not profitable to do changes to the code unless you just have actually measured a place where it's good to do so. Now, when I'm looking at this in React, the thing that I'd like to avoid is like when I fold or unfold this particular node, I don't want it to even look at all these other nodes, right? That's a lot of what the overhead is going on here, is it's actually running code to generate virtual DOM to then diff against the real DOM, which is just a waste of time. Most of these nodes haven't changed. But I can't do that the way this is currently written, because this is currently written as pure functions, and there is no kind of should component update around these. So I'm I'm going to flip back to my actual start to fixes here, and we'll see the kinds of things that I've done to kind of refactor this to try to pull out pieces. So I clear my notes here. Okay, so where did I put in some measurements? So I've got the top level render data, and then what I've done is up here, render map, I made, instead of having this be just a pure function, I turned this into a component, a map component, so I could add a shouldComponentUpdate element to it. So I'm going to comment that part out yet so far. And then I profiled this call here saying, okay, I'm rendering a map. So how many times do I do that, and how much does it cost is what I'm measuring there. So if I come over here, let's reload that, and then let's reload the app. Fold open our problem child. And then look at our stats. So map's getting called, a little over 1,000 times, which is what we expect. We put 1,000 things in this table, and then there, are other maps up here, right? So there's the remainder of them, and we have to be careful about looking at the totals here. So the clock time was 3.4 seconds, but then we over accounted because some of these things are nested, right? Sorted one is inside of, etc. So we kind of added up more than we had. But if we look here, some of the calls to map, in fact, quite a few of them, right? The average, they're very quick, 3-5 milliseconds, right? They're not a whole lot, but since we called it 1,000 times, it ends up adding up. The average is just 3 milliseconds. But then, of course, since we called it 1,000 times, now we've got React in the background doing a bunch of diffing, and that's going to kind of eat us alive. So when I look at this, the thing that occurs to me in the case of Fulcro is that this is a table, which means its entries are going to be keyed by some scalar value, and then the value itself is largely going to be a map that contains scalars or idents, right? So I don't really need to walk any further recursively in these data structures if what's here looks like one of these leaf nodes, right? So what I can do is attempt changing shouldComponentUpdate of this thing that I've just made, which is what I had already done, to try to prevent React from having to do any work on a component. So shouldComponentUpdate gets past new props. We're not using component local state, so we don't have to worry about the new state. And we can get the old props by calling prim props or FP props on this, Fulcro's primitives props on this. This is a Fulcro 2 app inspected. And so I've got the current search term, the current list things that are expanded, the current content of the node, and the path I'm at. And I can get the old version of those. Now I don't expect the path for a particular node to change, right? It's a path in a data structure. So if I call the same node twice, I should see the same path twice. So, and I've added a kind of a shouldComponentUpdate profile marker here, just to measure how long the shouldComponentUpdate check takes. Now, when should I update this particular component? Well, I should update it if, let's see now, so I'm going to check here. I'm going to turn off this leaf thing. So if the search hasn't changed, right, I'm going to have to render it if the search changes. And this, remember, this is a set of paths that are currently expanded with these little things. So if my status as an expanded node has changed or content has changed, right, if any of those is true, I'm sorry, opposite, right? If my content's the same and my expansion hasn't changed and the search hasn't changed, then invert that. And I don't need the or there. That was an earlier place. So this is one kind of shouldComponentUpdate. I shouldn't bother updating if search is the same, content's the same, and whether or not I've changed is the same. And we're going to find that that's actually problematic, I think. Okay, so I'm going to click on this node and nothing happens. And the reason nothing happens is that this guy up here short-circuited, right? So this guy's content didn't change. His expanded didn't change, right? So really it's whether or not this leaf is really what I'm interested in. By saying that these three conditions aren't sufficient because this is a recursive algorithm. So down here in some nested render, that's where I was trying to change the expanded. Well, at the top, the expanded check failed, right? It said, nope, I didn't change my expansion. So you'll see if I fold the whole thing closed, it's burning CPU, and fold it back open, that's rendering an old tree again, and now the thing that I expanded earlier is expanded. So that's not so good. So that's where we need the extra check of I'm going to tell you to update unless you're a leaf. So if it's a leaf and all these things are true, and I flip that, then I'm saying basically leafs shouldn't update. And for Fulcro Inspect, that's actually a pretty decent optimization, I think. We'll find out here, right? So we'll measure, we'll fold something, we'll measure. Now see, STU was called 1,000 times, but map was only called 6. We'll expand, right? It's not super snappy, but it's also way better than it was. So we went from 1,000 calls to map to 1,000 calls to shouldComponentUpdate, and we can see that shouldComponentUpdate totaled a grand total of 12 milliseconds, and our overall time is significantly better. So let's just say, this was essentially true, right? We were always saying it should update, and so if we that sort of thing, see the 1,000 calls to map, right? We can see there's a big difference here. And so that's a big win for a fairly small change. Just by figuring out, is it a leaf? It's a leaf if it's a map and everything's a scalar in the vals of that map, where it's a scalar if it's not a map or a vector. And I guess we should be careful about the vector check here. We can make this a little better, right? This is currently buggy. I've made it faster, but if these things had ref to minis or ref ones in a lot of places, they would still say they need to update, when in fact they probably don't, unless those vectors have changed. So my thing is the content is the old content, and it's a leaf. Yeah, so there's a little bit of work to do here to make this work right in other cases, but this is the general idea of walking through here and trying to see where your performance problems are, how you can improve them. And here that was I had forgotten to clear them. And now just a little bit of work. I've already essentially more than doubled, potentially tripled the performance of this data viewer with just a few minutes of measuring and judicious use of shouldComponentUpdate.